Okay then. Well, without further ado, for a second time, here we go. Razvan, let us know what you got.
Okay, so I was muted when everybody said it's okay. Is it fine now, or?
Yes,
Yes,
it's
we're good to go.
We're good to go.
Okay. Hi everyone. I'm glad to attend this this new OpenSIPS summit. Unfortunately, as Bogdan said, we can't see each other this time, but we can see in person, but we can see each other online. So hopefully this is as closer as possible that we could get. Hopefully in the future we can get closer. Today I will be talking about the new call API we've developed and how you can do call management using it in OpenSIPS 3.1. We will talk about, we'll have a small introduction. I will talk about the architecture from system perspective, as well as the internal architecture, so you can understand how the new call API module works, and why not develop your own modules or your own components. Okay, let's get started. So basically what call API is, it provides means to trigger SIP traffic. So it's an API where you can trigger different commands and it will translate them to SIP traffic for example, for establishing calls, for transferring calls, putting them on hold, and so forth. So it's a simpler method of generating valid SIP traffic for your SIP clients. It provides the logic behind SIP and simplifies everything by simply running a command line or triggering a call, library call. You'll see that it uses advanced in-dialog SIP handling to emulate the behavior of a back-to-back or of an endpoint, but it's not really back-to-back. It's actually 100% SIP proxy compliant, as OpenSIPS is a SIP proxy. In terms of implementation, it's a completely standalone tool. So although it is part of the OpenSIPS environment, let's say, it was not designed to work only with OpenSIPS. It is a standalone tool. It's written in Golang, so it doesn't have anything to do with the OpenSIP code base, let's say. It just provides a few connectors to interact with OpenSIPS. But as I said, it was not necessarily 100% OpenSIPS oriented, but it can also be configured or integrated with different tools, with different other proxies, as long as the interconnection is available. It provides a JSONRPC interface over WebSockets. And there are also some CLI tools available in the project that, in case you don't have like a JSONRPC over WebSocket application ready, you can play around with the CLIs that we've developed and provided in the source code. It has a very modular design. I will talk a bit later about the components that are part of the call API internal design, but it can be easily extended to support other commands, other behavior than the ones that have already been added. It is very scalable. So scalability was one of the main concerns that we had when we developed this. We want it to be as asynchronous as possible in order to make it scalable. And we are relying on the efficient Go routines. So it's written in a parallel and efficient manner using the internal Golang routines. From the high level design, basically Call API interacts with both the application layer, which is the one that triggers the command, as well as with OpenSIPS, which is the one that issues the SIP traffic towards the SIP user agents on the right. We have a WebSocket over a WebSocket connection to the application layer, where the application will trigger commands to the Call API, which will further forward those commands to OpenSIPS. OpenSIPS will do its magic, let's say, and feed back events to the Call API, which are further relayed to the application layer. So basically, in terms of interconnection, we have to provide interconnection with two different types of components. On the application layer, we have WebSockets, which are we have JSONRPC requests and notifications, which are sent to the Call API through the WebSocket connection. And I'm insisting that there are two different types of let's say, events. Requests are the commands that are triggered from the application layer, but as soon as a request is issued by the application layer, only parameters are validated. So the command itself, like starting the call, is not performed immediately. As soon as the command is received, parameters are validated, and if everything is okay, a reply is sent. So usually the command terminates in less than a couple of milliseconds. Further notifications are then sent back to the application layer in an asynchronous manner using the JSONRPC notification engine. So most of these notifications are asynchronous, so they are sent after the JSONRPC command is answered, and they can come like minutes or a few seconds up to minutes later than the command was actually triggered. So from the application layer, you have to create some sort of JSONRPC session, which consists of the initial request and all the further notifications up until an event ended notification is sent. We decided to use this approach because it was very scalable, and it allowed us to create very fast and very decoupled session-like communication between the application layer and the Call API. The second interconnection that needs to be done is with OpenSIPS. So again, we have two different directions that we need to communicate with OpenSIPS. One is tell OpenSIPS to do something, and we do that using MI commands. So we trigger an MI command, and that command can be handled synchronous or asynchronous. However, we don't get all the data in the response of that MI command. Most of the data are triggered again, are eventually triggered by OpenSIPS using the event interface. So we rely again on this mechanism to create a decoupled session. We don't want to create sessions or transactions, or like long-term transactions between the call API and OpenSIPS. Like, we don't want to have different Go routines sending a command and waiting for minutes or seconds for responses from OpenSIPS. Everything has to be as asynchronous as possible. And this was the mechanism that we decided to use. Furthermore, we are using all these using the datagram modules in OpenSIPS, both MI datagram and event datagram. The reason we're doing this is because these are fully asynchronous. Both these modules have fully asynchronous implementations in OpenSIPS. So this means that if I send a message, a request on one interface, I may receive the reply on the other, in a different process. If I were to use something like JSONRPC or MI HTTP module, I would have to use the same process to get the response, but not in the datagram MI implementation, where I can receive the response from any other process. Again,
so, let's say that is totally non-blocking. So it's not both at the level of the network and at the level of the application.
That is correct. That is 100% correct. And that was the reason that we designed it like so, just to make sure it is as synchronous as possible, so we can scale it as much as possible. In order to understand how interconnection works, I'm showing you a diagram with different communication between the different external components. So we will study the call start command of the call API. How it works, we have an application here on the left side, which is triggering the call start command using using JSONRPC over WebSocket, and it's sending it to the call API. The call API will send the TUSC command, instructing OpenSIPS to send an invite, and then it will immediately reply. It will immediately reply before sending the TUSC command, MI command to OpenSIPS. As soon as the command was sent, a notification is triggered to the application saying, hey, the transfer has started. In parallel, OpenSIPS is sending an invite to the SIP caller, and as soon as the SIP caller responds with a 200 OK, then another event is sent back, another JSONRPC notification is sent to the application saying, hey, the caller has answered, or the A party has answered the call. After the event is sent, the call API triggers the call transfer command, which is again asynchronous, which basically sends a refer to the caller, waits for indications that basically the caller will have to send an invite to OpenSIPS, which invite will send further to the callee. And as soon as the 200 OK is received, this event is relayed back to the call API using a different eCall transfer event from the event interface layer, and another event is sent to the application saying, hey, the call has been answered, and there's a missing event on this side saying, okay, now this call start transaction is ended. So the call start transaction is completed. You will see, and I will show you during during the demo, that all these events contain useful information. For example, what is the call ID of the call that remains established between caller and callee, right? We will use this. We will need this call ID in order to perform different other operations on that call. For example, put the call on hold or terminate the call. And again, I will show you I will show you how we can do that during the demo. Again, what I want to emphasize is that, and what Giovanni also noticed, everything is very asynchronous, although it might be a bit complex from the development side. It is very scalable and very very production ready, let's say. So it can be easily put in production because we don't really have to to have concerns about scalability. In terms of architecture, Call API consists of several components, and I will take each of them one by one and try to present to you what they can do and how they can be, let's say, extended in order to provide more functionality to our Call API. One of the components is the connection component. This component is basically the one that handles the communication with the application layer, but only handles the connectivity, like the networking level. Currently, we have two different implementations of this connection component. One of them is the JSONRPC WebSocket, which is what we will be using now. And there's another, let's say, hidden connection that our Call CMD tool uses. And it's basically the lifespan of the connection is it lives as long as the Call CMD session lives. Basically, it only lives as long as a Call API command is available. As soon as it ended, basically the connection will be terminated. Why I'm insisting about this component is that there was already a question on YouTube. Why did we choose WebSocket over WebRTC? And I'm going to answer it a bit later during the Q&A session. But what I wanted to point out is that if you want to do whatever other implementation or whatever other communication, you can just extend this component, right? So you can have, for example, what do you call it? XML-RPC. That's what I was going to say. XML-RPC interconnection. If you want that, that's just fine. You simply have to implement two different methods. One is for managing the connection lifetime, and the other is for sending notifications back to the application layer in whatever manner you want to do it. But all you have to do is implement this or extend this connection component. The next component is the CMD component. That's basically triggered when when an application layer wants to use the Call API, it will first initiate a connection, network connection to the Call API, and then it will send a command. It can, of course, it can issue as many commands as it wants. It can, the responses might come in different mixed orders, but that doesn't matter that much because we have a command, and this component is able to manage the lifetime of a triggered command. This command, as I said earlier, you can have multiple parallel commands on a single connection. That is perfectly fine. That is perfectly legit. Again, JSONRPC allows you to do that. That's why that's one of the reasons that we wanted to use it. But again, it might not be the only one. So basically, this component.
Interrupt, Razvan, but it's exactly what Giovanni said before about the scalability. I mean, the ability to actually aggregate multiple commands and responses, I mean, events to the same connection really scales. For example, if you build an web portal with a backend connected to OpenSIPS or anything like this. So basically, you don't have to kill your application with thousands of connections to the API just because you want to run 1,000 of commands.
You could if you want, but you probably don't want that. I totally agree. So it's not a limitation to work only with one connection. It's just that you can have multiple commands through one connection, but you can have as many connections as you want. But as Bogdan said, it's probably not a wise idea to open millions of connections to the call API. You can, for each command that you want to trigger, you can reuse the connection for different commands. Another component is the proxy component. And I was saying earlier that this proxy component was written in such a manner that it doesn't have to necessarily be OpenSIPS, but it currently works with OpenSIPS and it works pretty well. I will show you a bit later during the demo. But if anyone wants to have his own proxy implement this or use the call API, he will be able to do it as long as he implements the necessary connections. I will present them a bit later. So what this component does is it handles the requests to the proxy, in this case to OpenSIPS, and is able to get the notifications back from the proxy, in this case the event interface notifications. This proxy implements two different components. The ones that trigger the commands towards the proxy, in our case towards OpenSIPS, and the ones that handles the events. And I will talk about these components in the next slides. So in all this environment, OpenSIPS is just one proxy component of the call API. He's the one that implements the SIP logic. He's the one that receives the calls from the call API and translates them to SIP packets and replies and so forth. He also needs to intercept events from OpenSIPS and translate them to notifications, in this case to JSONRPC notifications. So basically what we had to do in order to use OpenSIPS with call API is to create two components, the MI component and the EVI, the event interface component. And we decided to implement them over the datagram, as I said earlier, because it was the most lightweight manner to do it, and because datagram is asynchronous. This allows us to scale as much as we can. I've talked about how call API works and the interfaces that it has and the components it has, and the fact that it communicates with OpenSIPS. And of course, all of these are true, but let's talk about on OpenSIPS side what we have done to make this work. Because although you could have done it before the call-ops module, this module makes things very easy for you. So instead of having to use the transaction module to generate all sorts of messages for call start, call transfer, put the call on hold, and so forth and so on, you can simply use this call-ops module, which basically integrates a lot of logic to perform, integrates a lot of logic that can be used to manipulate ongoing calls. For example, you can, having a started call, you can put it on hold, or you can transfer the call in either attended or unattended scenarios. So both are supported. Moreover, it provides a lot of events that are internally, some of them are internally generated by OpenSIPS, some of them are generated by the user agent clients, but this module aggregates all these events and brings some, let's say, order into them, packs them in an event interface and sends them to the call API. So although, as I said, all the stuff that this module does have already been implemented or could have been implemented in older versions as well. However, this brings a bit of clarity and a bit of order between all those actions and all the events generated. Without this module, it would have been hard, for example, to intercept notifications regarding the transferred call and push them back to the call API. It wouldn't be impossible, but it will be a bit harder. You'll have to have a lot of logic in your OpenSIPS script. So this module simplifies all this. What it does, it basically generates SIP traffic and intercepts the replies for the generated requests and does some sort of logic. It is very important, as I said earlier, that is not a B2B UA. So everything is done at proxy level without acting as a B2B UA. This brings a lot of scalability in OpenSIPS. The way it does it is it's simply by injecting some in-dialog requests. For example, it will generate re-invites for on hold, for putting calls on hold, or it can also generate refer messages for transferring calls. Again, it intercepts the replies and triggers either success events or failure events based on the replies received by user agent clients. Most of the implementations are done by the module. So simply by inserting it in simply by loading the module in your script. But most of the stuff can also be triggered through MI commands, for example. So you can have your call, and you from MI just say transfer me this call to this particular destination, and everything will and the call the refer will be generated and the call will be transferred. A couple of commands that are available in the call API module is to start the call, to terminate the call, to put a call on hold, to resume a call from on hold, and as I said, the two call blind transfer and call attended transfer to transfer a call or link two different calls together using call attended transfers. Of course, many other commands will probably appear, and we definitely need your help as a community to give us ideas of what kind of commands you are looking for to develop for your application. And why not, for those of you that know the Go language, contribute to the project, as it's fully 100% open source. Here you have a couple of references. So as I said, the call API is a standalone project, is within the OpenSIPS namespace. We have the documentation online. All the commands are documented, as well as the events that they generate. The call-ops module and description about what you can do with it and how it can be used. And there's also a blog that I've written a few weeks, if not months ago, regarding how the new call API can be used to do call management. So check this out and play with it. I will also show you a couple of stuff that can be done, but let me stop my presentation and set it up. Okay, so we had this demo before. We had this layout, like this architecture layout, where we have the application layer, the call API, OpenSIPS, 2 user agent clients. Well, I've already set this up on my testing machine. I have a virtual machine here in my in the office that is already set up. I have OpenSIPS installed. I have the call API installed and configured. What I'm going to do is, instead of the application layer, I will use a browser. I will use a web interface that will be able to issue WebSocket JSONRPC over WebSocket events to the call API and start a call between 2 different user agents. I will also use Alice and Bob, which are Alice is basically a limb phone on my computer. Bob is a hard phone next to me here, and I will also use a third. Actually, I will use the call CMD tool. That's part of the call API project. I will use it to transfer a call established between Alice and Bob to a third entity, which is Carol. Here again, another hard phone on my desk.
While Razvan is preparing, I just want to show you that we are really hard working on this kind of scenarios with Alice calls Bob. We actually even have a mug. I'm not sure if you can see it, with an Alice calls Bob mug, right? So it's a SIP mug with the whole scenario we have over here. The SIP
yeah, so that's how we inspired to make
on this side.
Okay.
Oh, you have Carol. Okay, that's good.
Who should we have? Sorry.
I mean, the third party, there is a Carol, right?
Yes, it's Carol. It should have been Max, but sorry about that.
But it used to be Charlie.
Charlie. Well, I like Carol more.
Yeah,
Sorry
him
about
more.
We are very feminist area. We are choosing female characters to our endpoints.
Yeah.
Yeah, but Charlie can also be female, I think.
Ooh.
Okay, I like Carol more.
Also Alex.
It's not that I hate Charlie, but Carol is more interesting.
Charlie's watching you. Carol's answering the phone.
Okay, I'm sharing my screen now. Oops. Okay, so what you should be seeing now, I'm not sure if you do, is a small interface that I've developed during one day. I always start with this because I'm not a web developer and I know that my applications really suck at UI, but trust me, you guys can do this a way better job than me. This was just my few hours experience of putting inputs inside a form. So bear with me. That's all I could do.
Did you use Microsoft Front Page for this? I need to know what your tools are.
No. To be honest, I'm not sure. I'm using Bootstrap. That's all I know. I've used Bootstrap. So here, as I said, I already set up OpenSIPS and call API. If you want me, I can show you here. I have a call API console, which is listening on 10.0.0.227, which is my my virtual machine IP inside my network. Okay, I'm trying here to
Razvan, increase a bit the font just to be sure that everyone. This one, yeah, more, yeah, that should be fine. That's okay.
Let's increase here as well. Okay. Okay, so I have here an SNGrep page, an SNGrep application, which I will use to show you how the call establishes. So let me simply start the call. So I will call from Alice to Bob. Not sure if you can see, but here Alice is calling in my lean phone. So I will answer the call. And now, as soon as I answer the call, Bob is starting to call. So I will answer the second call. Hello, hello. Okay, I can hear myself. Not sure if you can hear, but trust me, this works just fine. Let us see how this works from SIP perspective. So here you will notice an invite was sent by 10.0.0.227, which is my virtual machine. It was looped back to OpenSIPS and relayed further to 10.0.0.12, which is Alice, is my lean phone. It started ringing, and as soon as I answered, the 200 OK was sent back, act, and so forth. As soon as the call was act, a refer was triggered to Bob at summit.opensips.org. Note that this also contains an OS ID. This is the call ID of the dialog. So we use this call ID in order to be able to link the two dialogues together when the second invite comes in. Here you'll notice that the refer was accepted. There was another re-invite putting the call on hold, as you can see here in the trace. And then the second call is this one. There were two attempts for not acceptable here. No media was found here and here, but the third leg was answered by my lean phone. And in this case, as you can see, there's another invite. Sorry, just a second. There's another invite issued from lean phone. What do we see?
Click hide.
Sorry?
Click hide on the little floater.
Okay.
Where it says stop sharing, click hide next to it.
Okay.
Hide.
Oh, hide. Sorry.
Yay.
Thanks. Awesome. Thank you. Okay. So this is an invite triggered by my lean phone, goes to my proxy, which is relayed further to Bob. Okay. This call was answered, and now the call was established. This one should have been terminated here. So a buy was triggered in order to terminate the initial call. So now I only have a call from Alice to Bob. The same can be seen here on my small web application. For example, what I can do, another operation that I can do is to put the call on hold. Let's do it. Not sure if you can see here on the right side, there's an event that was triggered by the application saying that the call is on hold. Do you see it? Or
Yes,
we do.
Hopefully. Let's see how this translates in terms of signaling. So we had here the call answered, and now we see this.
You may want to press C for having coloring by call ID.
Okay.
Again,
like
okay.
So, or
That's it.
okay. Okay, so you will notice that two invites were triggered by OpenSIPS, so by the proxy, which is in the center of this trace. One of them was sent to the caller, one of them to the callee, both of them containing the inactive inactive marker. So basically, the call is now on hold. I can see that on my yielding, so there's an indication that the call is held. And I should be seeing that here. Oh, okay, so this small pause button shows that the call is on hold. I will now resume the call. So the call is resumed. Again, the Bob can be seen here, so because Alice is talking to Bob, and I can hear the call just fine. Another thing that we can do is transfer the call, and I'm using a different console here. I'm using the call CMD tool in order to transfer the call. I want to transfer the caller to the destination SIP carol@summit.opensips.org. All I need to do now is to use the call ID that I want to transfer. In this case, I will copy the call ID from my interface, paste it here. I'm using this CMD tool because I didn't have the time or the knowledge, let's say, to add another button here to do call transfer, input a different destination, and so forth. But it would have been quite the same thing. All you had to do is take the information from the web form, send it to the call API using JSONRPC over WebSocket, and it's basically the same thing. Now I'm triggering the command. All these events are coming, as you can see, are coming. The call is transferring, the call has started, the transfer is pending, and so forth and so on. And you can probably hear my second phone ringing. Answering it. Hello? Hi. I've answered it. I've received a notification that the transfer is successful, as you can see here, and the command has terminated. Okay, let's see how this translates in terms of tracing. So again, after I clicked on hold, there were two other invites that have been triggered by OpenSIPS. This time they no longer have the send receive the invalid marker, so we have only send receive. Calls have been answered. Now you can see that a refer has been triggered towards the caller saying, hey, just refer or call carol@summit.opensips.org. Okay, 200 okay, accepted. The call was again put on hold. Act. There was a notification saying, hey, we're trying to do that. And as soon as the second call has been answered, a buy was triggered again by OpenSIPS. By the call API, actually it was triggered by the call API, but through OpenSIPS. And here we have the third call where Alice is calling Carol. Okay, call has been answered, and then I hang up the call. Actually, the call was not properly answered. I say that Limphone just triggered the buy. Okay, I need to check why. Anyway, it worked. So the call has been properly transferred by my Limphone. So everybody should be happy. So I hope you enjoyed the demo. This was what I wanted to show you. Okay, now the call API tried to end the previous call, which was the call from Alice to Bob, but it no longer exists. That's why we saw those errors. As I said, of course, this demo needs a lot of improvements, and I'm probably not the best guy to do it. But we are looking forward for any help that could be that could come from the community. Okay, thank you very much for attending this this demo. I hope you liked it. Let me know if there are any questions.
There are lots of questions. We're gonna have to trim them down now.
So happy.
Yeah, so
Um,
you have to give me a beer because I already answered like 3 or 4 on Slack. So while you are presenting, I care of on the question on Slack. So
Thank you very much.
Guy, his hour wasn't enough. He's got to like steal the thunder from everybody else.
Well, he had
So,
some audio.
let's see what is coming from YouTube, Alex, if you can check.
I am, and basically it's the same. What we do have though is the question about the call ops being able to handle refers from MS Teams.
I already answered to that. Mainly no. I mean, they're completely different scenarios.
Okay. And then there was a question from about once both parties are connected together, can we resume such a call in the same manner? Can we inject some other SIP message into this call, like message or info or options, etc.?
Yes, definitely. So basically, it will be a regular call initiated by the user agent client. All we do is just create a call to the phone and ask him to create another call to the real callee. As soon as he does that, we will close the initial calls and it will behave just as a regular SIP proxied call, where we can do whatever we want with it.
Okay, good. There was another question on whether you plan to add events to the call states, such as ringing, answered, etc.
That's a very good question. We don't have that, but we can easily add it. So yeah, just open a feature request, or I will write it down, and it's not that complicated to do it. It just hasn't been done because we didn't think about it.
I'm trying to wrap in my mind around the new API. I will study the documentation, etc. But one possible application for that, but maybe I'm wrong, is solving easily something that normally takes a lot of logic to be solved. And there's, if you think at, let's say, some PBX in the cloud or something like that, you have various levels. You have the phone, the proxy, the media server, or the free switch, asterisk, whatever. Then you can have the RTP, so the media, can go directly between phone and phone, or can pass through RTP proxy or RTP engine, or pass through free switch. So passing through and RTP proxy and then free switch and then come back. So the RTP can be at least in 3 different places. And so, for example, you want to have the RTP flowing locally just to have a lower delay, etc., as much as possible. So stay in the LAN. But then you have music on hold, or you have conference, or you have a refer, etc. So it becomes to be kind of difficult to act on the SDP, on the RTP proxy, and on the media server, on the free switch, to manage the RTP flow at those 3 different levels, and with the interaction through on hold, etc. And it seems to me, I'm not sure, but it seems to me that with this call API, it can be at least a little bit simpler than before to manage this continuous changing of the RTP flow.
Unfortunately, I will have to disappoint you because no, it won't be that easier with the things to the new call API, but it will be easier with the media exchanger. So yeah, more or less, hopefully I will show you on Friday that you really don't
You guys are giving us so much things to learn and I mean, be enthusiastic about. Super.
Awesome. So there's some sort of another question regarding the why we have used the JSON-RPC over WebSocket, and that was because it, according to our research, was both an asynchronous protocol, so you had both requests and notifications, as well as it was easier, it was very efficient and widely used in the web world. Moreover, we thought of people trying to develop other interfaces, and that's why we made it so modular and so easy to add more how do you call them, application interfaces. We will definitely take a look into JRPC or REST APIs. Not sure, however, Flavio, I'm not sure whether those protocols do support both requests and asynchronous notifications. Of course, it doesn't have to be notifications per se, because you can also create a request on the other in the other direction. But for example, from the application layer, in order to receive some notification, if the protocol doesn't support it, you will have to create your own listener and provide it to the call API so you can get the notifications back and so forth and so on. I don't have that much expertise with JRPC, but I'm pretty sure REST API is not able to do that.
Because the standard right now for the APIs is REST APIs. And usually when you do the notification, you do it through a webhook. So the most usual way to do it is through a REST API and a webhook to get the notification back. And gRPC is bidirectional. So you have both channels in the protocol.
That's
and
interesting.
There are some API platforms such as API Connect and others where you can proxy a service, but you can proxy a service if it's based on JRPC or REST APIs or SOAP or even MQTT. So it would be interesting to have a standard protocol for an API. JSON, obviously you can do it over WebSockets, but it's not very standard in the API world, in my opinion.
So for example, the JSON JavaScript library that I use was quite easy to integrate because it was already there. Regarding the webhooks, more or less they were a no-go for us, because for a webhook you have to be reachable from like an IP level. It would be very hard from a browser perspective, for example, to get notifications through a REST API. To be honest, I don't know how to do that, but it might be possible.
Let's suppose if I was to build a dialer using the call API, I would love to have REST API and a webhook. So I will push the calls over the REST API and receive the replies and the notifications over a webhook. And on top of that, obviously from a browser is a little bit complicated. But gRPC, I believe it's bidirectional. You could do in both ways using a standard protocol. It's just an idea.
Let's check it out. Thank you very much. That's why it's open source, right? to put as much as knowledge in it as possible.
Razvan, because we are like already overflowing a bit, there are some fast question collected by Maxim from YouTube. So there is a question: can we add custom headers when using the call API? I think it's from Gril Galinurov.
Okay, currently not, but that's easily done. So you can do that, not at least not from the call API itself. You'll have to code it in OpenSIPS local route script. It's not that hard to do it. It's just not something that we needed. I mean, it's probably just a change in the call API. So any feature request would be easily implemented.
Also from him, it's like a follow-up question: can I modify the invite originated by the call API at the script level?
Definitely, yeah.
Which, yeah,
using a local route, yeah.
Short question from Maurice Edery: does OpenSIPS CFG needs additional configuration? I guess for the call API.
It does, and there are basically 5 lines that have to be added. I had a presentation during ClueCon. During ClueCon, yeah, sorry, a while back, that shows like the 5 lines that need to be added. Nevertheless, I will provide the configuration script I used for this particular call, so you can see. The blog that I presented also has all the details for configuring OpenSIPS, but again, it's just a matter of loading 3 modules, actually 4 modules, and adding a line for treating in dialog notify messages. That's all.
And a last question. So sorry guys for eventually misspelling your names. I'm not familiar with all the names. From I guess Igit Zorlu. Can you talk a bit more about the potential use cases? I'm not sure exactly what was the context of the question, if it's about cases like commands or whatever. So
sure. So the idea is that you can do some sort of manipulation of ongoing calls, like starting new calls from using different means than staying in front of your hard phone and dialing a number, like pressing the keys, the phone number. You have tools that you can automatically use. You can develop your own application, as I've shown you in your command line, in your browser, let's say, and just click on a button and start a call. For example, in a call center scenario, you can easily transfer a call to an agent when you see that fit, let's say. Just go in a browser, press a button, and the call will be transferred to an agent. So that's one of scenarios that I'm thinking of right now.
Quick yes or no question. Does it support attended transfer or only blind transfer?
Both of them, both attended and unattended.
Amazing.
Yep.
Okay. I think there are like more questions, but we need to. We are already.
The Slack.
We're already late for the next presentation.
Yeah, let's switch. We can continue whatever questions you have for Razvan. Feel free to use the Slack, the Summit chat conference. Also, we can take the questions over there. No worries.